So thank you very much for coming. And by the way, it's a challenge to give a talk after previous one. That was just excellent. It was multimedia, everything. I'll have static slides to my embarrassment. But yeah, so this is a guy who is me, who looked like this a couple years ago. And I'm embarrassed to say that I wasn't streaming since '97, since real video. Most recently, I was with BrightCove for about 10 years, was running their R&D. And now I'm mostly retired, but I'm still staying active as a co-chair in SVTA, running several activities, including co-chairing DASH-IF subgroup, as well as players and playback and coding packaging. And I'll talk about a few things that we are doing in these groups to help industry to move forward faster and more consistently in the future in the world of multi-CDN streaming. And why multiple CDNs? Well, many of you using them. I've seen many hands raised. And you know that if you're at certain scale and you need to achieve good reliability, switching between CDN is pretty much a necessity. The honest answer is that all CDNs are great, but once in a while you have issues. Once in a while, and those issues can manifest themselves two ways. It could be a serious failure, outage, where you really need to move all traffic off the CDN, or it could start degrading. Or some CDNs start doing something creative, like routing players in particular time, particular regions to POPs in some other regions, which of course will increase latencies, and of course you will notice it in analytics, and then if you're doing things right, you probably need to do something about it. So switching it for not only failover, but for performance reasons is another good reason. And of course, load balancing allows you to increase the scale. And if you do it right, you could manage costs. And of course, it makes system more viable longer term, and maybe helping with sort of navigating changes in CDN rates and so on. So with this, these are the motivations for doing it. It's with multiple CDNs, but of course there is one little caveat, is that switching traffic from one CDN to another is not exactly trivial problem. And if content is static, like web pages with images, well, DNS works pretty well. But once you have timeline and you need to do it in real time, switch mid-sessions, DNS-based switching has certain limits. And with different sort of DNSs and different reaction times of DNS servers in different regions, the failover switch is not going to happen instantaneously. It might take different times in different regions to do the switch. So DNS is good and wonderful for static content. For real-time media, it does have certain limitations. But it is one of the instruments around, and many systems are still using it, but with some caveats. Manifest rewrites is another technique, but it also has certain limits. For example, if you don't control how manifests are generated, you might be presented with very miraculously produced manifest which your parser might not parse correctly. If you look at all annexes of Dash and syntax that it allows to do, there is a space of creativity that no practical parser will follow. So server-side routing, it's another technique that sounds promising, but then it adds complexity, because your servers also needs to be on scale if they want to do the traffic steering. There is a cost of managing them and so on. Client-side also sounds like ultimate solutions, because in client you could put ultimate logic and do real-time decisions on which CDNs to pick, but then what you do with platforms that don't allow you to change clients. So none of this existing techniques is a silver bullet, essentially. And so in the course of last 5 years, there was an activity that started effectively by Apple and then picked up by DASH-IF and now SVTA, and it's called content steering. So this is a standards-based approach of how to implement switching between CDNs and how to make it robust, future-proof, and practical, and unifying in the future. So that's the subject of this talk, and I'll sort of give you a history of development of the standard, where it's going, what are the benefits, and what it brings. And this is the idea of the standard. So if we look at the delivery systems with two CDNs moving data, which are called CDN1, CDN2, or we can call pathways going through the CDNs as alpha and beta. And for simplicity, let's think that manifest sitting somewhere else. Then what you can do with content steering is you could create another server that could regulate the switches between the CDNs. So the CDNs are connected. Manifest includes annotations to both, but the content steering is the entity that now tells clients which CDNs to use. And the exchange is shown above. You see that the client can ping a steering server at certain periodicity, tell steering server what is the current session, what is the current CDN it's using, what speed it's observing by using this current CDN. And then the steering server could respond back saying, okay, please now use CDN beta, for example, as higher priority CDN. And that will be based on analytics and real-time metrics that the steering server will have, and those metrics might be available to that entity and not available to client. The client usually sees only one CDN and doesn't know how other CDNs in the same region perform. So moving it to additional entity allows more comprehensive processing and more meaningful decisions. And beautifully enough, what happens if steering server also doesn't work? Well, the client still keeps pulling data from whichever CDN it is until steering server responds. So it doesn't break anything. It adds accumulatively to existing system. And beautiful part of it is that even the client is legacy, it doesn't understand steering server declarations. Well, the system still works. So you could add incrementally, roll out incrementally this technology in existing deployments. It's not going to break anything. Very simple path to productization and deployment at scale. So benefits. So the key problems that previous techniques struggled with solving is how to switch midpoints. And the only type of solution that was addressing it was client-side solution, but it was not available everywhere. Here, since the actual decisions when to switch still belongs to client, and steering server only saying, please switch. And it is up to client to manage its buffers and do the mechanics of aligning timelines at which to switch. It can do it seamlessly. And second, you could actually do some advanced functionality with this technology. You could introduce new CDNs in the middle of session. You could realize that in this particular region, there is a local CDN that is cheaper or that is effective or that is more available at this particular point of time and introduce it dynamically. So you don't even need to change your manifests and whole workflow to do things like this. So this steering servers and content steering mechanism, you could sort of make your whole system dynamically reconfigurable in real time. And that is what the system brings you. And it is robust by design. As I mentioned earlier, if steering server fails, the client's still playing, and clients must still use their sort of default failover logic. If one of the CDNs stops responding, it just picks another one. So it's all compatible and nicely coupled with existing design. And at SVTA last year, we ran a pretty massive study with 3 commercial CDNs with all regions and with quite a bit of statistics collected with users joining the sessions at different times and trying to play it. And what we observed is that with pretty simple optimization, QA optimization logic that we built in, we reduced buffering ratio by 14x. And that's quite significantly. It's up to 14x, I must say, because in some regions, like in India, it was 14x. In some other regions, like France, where CDNs were pretty good, the worse is the situation, the better the gains you're getting, obviously. But the numbers were pretty compelling. And it took a while to build it. In fact, the first proposal was by Apple in 2021, and initially it was only HLS. So DASH-IF came up with a complementary proposal for Dash ecosystems, and it took a few years to mature this technology, to build client support, to build encoders, packagers, to include proper annotations in the manifests. And it took a few years to publish the specifications. And the beautiful part is that about 2 years ago at SVTA, we started talking to Apple and saying, hey, we want really to have a single specifications moving forward. We don't want to have Dash developing its own extensions of steering protocols that will work only for Dash, and then HLS camp developing HLS extensions. So we have to build now 2 different steering servers. Let's make things unified. And then it actually got picked up. So we are on the path to have a unified standard that will kind of help us to move in the future in very predictable and meaningful on a meaningful trajectory. So media support, we have multiple players supporting it. Obviously, Apple AV Player was the first to add it, HLS.js, Video.js, Shaka.js. By the way, I think I have some developers from Video.js that added this support in the, and of course from Shaka, kind of integrated this support pretty quickly. Of course, proprietary vendors added Bitmoving, Brightcove. Most recently, and big addition was from Exaplayer, from Android. So if you think about players, there are really 3 sub-ecosystems. One is web ecosystems with JS-based players, there is an Apple, and there is Android. So now we covered across all of them. And several TV manufacturers, and they're adding this technology to their players as well. So it is pretty well covered at this point. Similarly, there are several implementations of packagers, and there are even whole systems built to support it. So Cinemedia, now Vortex has complete system. Broadpeak is working on this. Veloxis is adding support to their system. So it's a pretty good momentum. And of course, there are tools available as open source components through SVTA. And if you just search GitHub. And there is also one more activity, which is called 5G Merge, which I'll talk about later, that adds extra feature to the project. So I mentioned already briefly that now we're moving towards unified standard. And so this is the trajectory. Initially, there were 2 tracks, and we're in final publication stage now for joint content steering specification. And so HLS has already updated the sort of HLS v2, an official name, which is 8216 bis to be compliant with this common reference. And the activities that I run in DASH-IF is updating the DASH-IF spec to cross-reference to this common specification. So the future is common and it's bright. And this is a description of what the standard unified. The steering server manifest, the functionality of steering server becomes completely uniform and across both systems. Base client behavior is also specified there, but there are, of course, some specifics on Dash and HLS with respect to how HLS and Dash manage manifests. So there will be some differences. But this is a new frontier. It turns out that this technology might help not only with switching CDNs. There is also now hybrid delivery systems using satellites and CDNs in the loop, and satellites used, of course, for remote regions or in some places where it's actually cheaper to use satellites and more practical to use satellites. And it turns out this technology can help very meaningfully in steering traffic. Sometimes you might have multiple satellites that are available, and you could steer traffic between multiple satellites. So the ability to sort of push handoff to the client, where the client knows the state and can do it seamlessly, it's a critical feature that now helps in completely new context. So this is a now space age technology. Boy, literally. Okay, with this takeaways, it's mature and open. Its unification is there, future is bright, and growing application space. So if you haven't tried to use it, take a look. There are all components out there. Moving forward, using content steering is most sane way of managing multi-CDN delivery. Thank you very much.